Hello, today we learn computer system, organization, and operating system. In this chapter is 11. I will learn about the threads. After your study, you will know about the mechanism of threads and process. I have a C++ language code to show you uh, a situation about the critical section rest condition, and you can experience about the problem of the critical section rest condition, Livelock, and Starvation. And you will have a C++ language. You can download the code from the internet, but you don't worry about the write code because I show you in the video and learn to show you the output from the C++ language that generates a critical section race condition. There are the topic. We have the two main topics. We talk about threads and problem about the multi-thread. This is background. And here, the thread. What is thread? On the right hand side, this is a memory. I start up to three application. After I start three application, the application load on the memory. We call the active process. Active process that have three active process, and this is a process ID like as a citizen ID, but this is an ID for the application or running in the program. Is this ID is not the same number generated by the operating system. After you are close or terminate the application, this process will remove moving out from the memory. This is no active ID and active process on the memory after you delete it. When you click to start the program will create a process in the memory. In the process have a two main part. The first main part that we call PCB. PCB, what is PCB? PCB is a group of the variable. Group of variable that means it's small variable that's used to control the process. That's keep about the priority, memory location, and process state. If you remember from the last weeks, we talked about the process state. That is keep the status in the PCB. And this is in the red box. This have two red box, thread 1, thread 2, and the process 210, 210. And here this is have a three three thread box, and only process tends have only one thread. Number of the threads depend on the programmer. Programmer design the number of the threads for split the works. If you have more threads, that means your program run like as a parallel processing and match to the multicore processor. Meaning of the thread is a small function or a part of the code. I will show you in C language code about the thread to in the program. Number of the thread limit by the programmer design and limit by specific of the works and also the memory size. A problem when a problem of single thread and in the multi-core system. On the picture above here, I start an application, create a process in the process number 10. In this process have only one thread. This process run on the multi-core CPU, and here this is a dual core CPU. When I run this process in this process run and use only one core. I run the core number 1 And core number 0 is a free, not processing or process another author 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 process. On the bottom, here I have a process number 210. In this process have three thread, thread 1, thread 2, and thread 3. When this process active, that thread 1 run on the first core, thread 2 run on the second core. Exactly, here this, in this run only 50% performance for running. And here in this run on the 100% of performance for using multi-core system. Now I will show you the activity 11.1. In this activity, I show you only the code and output from the code. I don't write the code to run the program. You can bring this code to run on the Visual Studio. Visual Studio now I use a Visual Studio 2019. You can copy this code here to run in Visual Studio 2019 and click start. The program will generate output like this. Okay, before we look at the output, I will explain to you in this code. In this code is C language and I write in C language style in C++ code. Here I write the code have two function, function A and function B. And here this is main function. The main function is the first function start by when you click start to run the program will start at the main function. You have only one main function. When the will kick start, the program run at the main and program move to the function A. Here I start. When I start, the program run on the main and program move to the function A. The function A, call the function A as jump to the function A. To run in code in the function A. After run complete, is moving back to run remaining the code that's called function B. Move to the function B again and run the code in the function B. After complete, is moving back to main to run the remaining code. The part of program doing like this. Okay, so when you are running this code, the output will show like this. The output is generate the hello world 100 message from 0 to 99. And here after that generate hello world B from 0 to 99 again. That means after complete the function A in the run in the function B. Here this is activity 11.1. This activity process like as this. This is a use only one thread or no thread. Okay, now I show you the 11.2. Here in this course is different from the 11.1. Here, because this course is no thread, and here this course is have two thread A and thread B. In this course, you can use this code in Windows because I use include windows.h if you run the code on Mac. And in my example, I explain to you, I show you here I run on the Mac system. I cannot run this code on Mac. I need to declare or change the include and also change the style for writing the begin thread. Okay, here in this code use is the same meaning of the 11.1, but is different by run in thread. This code have two thread, thread A and thread B. The program start at the after I click start here, the start at main, the main generate object thread my handle A, my handle B. This is object thread for handle thread, and here begin thread for start thread. After when is this code pass the begin test, that means it generate thread A. Thread A will generate thread A. After that, it will generate thread B. Thread A and thread B will run free without a path for running because this is serviced by operating system. After that is single wait for single object thread A and thread B wait for complete wait by infinite time. After complete both thread A and thread B, it will show get character to break the display. So here the output will not difference the path from this because this is a single core and here this is multi-core. That means this is generate thread A, thread A may run on the CPU, the first core CPU, and thread B may be run on the second core CPU. So the output from this activity will show difference depend on your system because depend on select the thread or to run on the CPU depend on the operating system. But the output will switch here in this example. Thread A run about three loop and then the moving back to thread B and thread A, thread B switch because the console outputs have only a single process. Test A run on the CPU core 1 and test B run on the CPU core 2, core number 1 and core number 2. The output from core 1 and core 2 is sent to the console. What is the console? Console is this display. We call it console. So the consoles have only have a queue to get the output from core A, core 1 and core 2. The output will display to you here. Here this is you display to you. So the output will show like this. This is a thread style for running, and when you run in this thread, the output will generate. The program will generate the code for distribute to your system if your system have the multi-core. In 11.2, this is matched to here like this. But here in this, I have 3 threads and 11.2, I have only 2 threads on the multi-core CPU. Now we will talk about the problem of multi-thread. Problem of the multi-thread, when you have a worker, you have a lot of worker. That's how you need to manage the worker working to get the high performance. Sometimes your worker, when you have a lot of your worker, maybe this is occur the redundant works and maybe occur the doing the same thing or doing the wrong works. That's just like as a multi-thread problem. Here, the multi-thread problem have the concern some text or some word relate to multi-thread. All of this, there are the words that you need to know after your study in this chapter. start the first that is the atomic operation. The second is critical section, deadlock, leaflock, mutual exclusion, race condition, and starvation. What is meaning of each word? Now we will remember the single thread. The single thread do like this. I have a function my counter. My counter count from 0 to 1 million. 1 million. That means this loop is 1 million. Counting by at the value g1 g at 1 to 1 million. So I have 1, 2, 3, 4, 5. That means after I run in this code computes the g variable. G variable is a global variable. What is global variable? The global variable is the variable that I declare the outside from this function. Example, I declare here int g I declare outside the function. So the g is a global variable. When in this function, g at 1 will write the output to the g variables. And here, after that, move to this in this update g like this, do the same thing. So the output from totally here is will be 5 million. 5 million. The problem when in this not occur the problem about the multi-thread because this is a single thread. We will talk about the first the multi-thread operate the multi-thread word that relate the multi-thread word that is atomic operation. What is the atomic operation? The atomic operation is a part of the code, that's like as the function, but this is a small code, a few line of the code. This is a few line of the code. That have the main point is protect the interrupt or break running. When you have a code, example, I have a long code here, code. When you have a signal, some example, I signal from keyboard, I place the keyboard. The keyboard will generate an interrupt, int, interrupt by the hardware interrupt to the operating system. Operating system will break the application to service the interrupt. So here, this for atomic operation, this is a part of code to protect the interrupt signal or breaking running. When the interrupt signal coming, the interrupt signal need to wait until the atomic operation complete. So here, atomic operation is have a few line and small, very small of the code. So we call this is atomic operation. In C++ in version 11, 2011. In 2011, Apple is have a standard style to manage about the atomic operation. And I cannot show atomic operation in C language because it's out of the scope for because you don't have experience to learning in C++ language. If I show about the atomic how to write in C++, maybe you will confuse about the atomics. So you remember only the atomics is a small part of code to protect the interrupt and break running. Now we will talk about the race condition. The race condition here. What is the race condition? The race condition is a problem occurred by the multi-thread access. Multi-thread that means a lot of threads access to the same resource. Access to the same resource. Example, I have thread thread 1, thread 2, I have two thread. Thread 1, thread 2, and thread 3. Thread 1, thread 2, and thread 3 try to access global variables. Here, try to access the global variables. What happened? When thread 1 write the global variable, maybe thread 2 write the global variable and thread 3 write the global variable at the same time. At the same time, maybe the outputs will generate the error because the global most of function of the global variable is sharing value to each works to each or thread. So when access like this is maybe generate the error. Example, I write thread in the function my code my counter. The output like this. When I have a 5 thread, I suppose when I have 5 thread, thread 1, thread 2, and thread 3, 1, 2, 3, 4, 5 thread, and each thread run individually by running function my counter. I generate the my counter in 5 thread. In each thread run by access to the global variables. Access to the global variables here. So totally, after I run all of these codes complete, the G value is not the 5 million because the problem occur when I suppose here delete. I suppose here so I suppose G right value 1 G like 1 thread 1 thread 1 right value 1 to G right value 1 to G and then thread 2 right read here and thread 2 found that G is 1 G at 1 G at 1 will be 2 during G right 2 here G right 2 during the G right 2 the thread 3 will come quickly to read the value G. The thread 3 get G value is 1. G value is 1. Get before the thread 2 writing. And thread 3 write thread 3 1 at 1 will be 2. Thread 3 come quickly. Follow thread 2 write 2. After that thread 2 write 2 complete. G is 2 and thread 3 come to the thread G again and write G is 2. Here this is a problem when the writing because it's G variable is a global value to share in the 5 thread and during read and write in microsecond or in the microsecond thread 1 write and thread 2 read and thread 3 read. This is a switching during the switching and not sequence occur and not correct the sequence, it will be generate the error output. So here in this, I show the output by I write I show the output in video. I write the code in window here. Here I will start the video. In this is a less condition. In this less condition, I have a 5 thread I have a 5 threads, and here this is my function, my counter, my counter 5 thread, and this is main function. The main function have a thread, and here this is thread start and thread join, and this is a G. This is global variable. Where is G? And this is G. And here int G is G is global variable. And this is a single test. I remove the comment from the single thread. Yeah, remove the comment from the single thread. All of the line from the comment. Remove moving out. Okay, after complete, I click start. Look at the output generated from the program. The output show like this. I stop the video. Here, this is a multi-thread, and thread 1, thread 0 start, thread 1 start, thread 2 start, thread 1 finish, thread 3 finish. Not finished by sequence from 0 to 5, 0 to 4. Finish depend on depend on running on the core, depend on speed on each core. So the output at G is in the multi-thread style is maybe is 2 million, 2 million point X. This is not correct. This is correct when this is incorrect. And here correct that this single thread have a 5 million. 5 million. I run this is output show for multi-thread and single thread. I run it again. Run it again. Here is it. The output is different. From the first experiment shows 2.8 million. And here this is show 3.7 millions. This is output from this is example of the race condition. I think you understand about the race condition. Now we will look at word about the critical section. What is the critical section? The critical section help race condition because the race condition occur when there are many threads, a lot of thread access to the same resource. The resource is global variable. Here, the critical section manage the run in the share resource. By the critical section allow only a thread can access the resource. This is called critical section. This is a critical section because this section is the critical. So that's called critical section. The critical section is a part. So here in this code, I use check critical.log means start the critical. And here this is stop the critical. When any thread, when I have example, I have 3 threads. Thread 1, thread 2, and thread 3. Come quickly to here. Thread 1 come first. Thread 1 lock and thread 2 wait. And also thread 3 wait. Thread 1 run complete. Thread 1 unlock. Thread 2 come follow thread 1. Like this. This is a critical section to manage locks and unlocks. And some students look at this is told me about here in this look like the single thread. This is the same meaning. This is like as a single thread. But when you compare the speed from here, maybe you use in this. This is a speed up over the single thread when you write the single thread style. because out of scope from the critical section, you can run in the multi-thread. You run in single thread in the critical section. Okay, here in this, we call the critical section. Do scope of the critical section, sometimes called the mutual exclusion. Sometimes called the mutual exclusion. Here I show you the critical section video here in this. In this video, look at this. This is critical section. Critical section. I start the video. Here in this video have a critical section and mutual exclusion, and in the video I test out the critical section. The critical section locks. I remove from this. No, I don't remove. This code like as a less condition, and here, and this is a single thread. This code look like as the less condition, and start. Now I click start the program. The output will generate the error. Its output will be G is 6 billion, 6 billions maybe, and G is incorrect. Here in this again. Now I change it to start and comment in critical logs. This will be critical section. And here this is critical section. That means in this code from line 22 to 25 is a critical section. This is the same result. Same result for multi-thread and single thread. Here this is a critical section. Now I think you understand about the what critical section and mutual exclusion. The critical section is when the thread 1 access to global variable or resource. Thread 1 will lock resource to access. That means thread 2, thread 3, thread 4, thread 5 lock cannot access to the global variables. Okay, when I compare the atomic operation and critical section, the atomic operation is a small part of the code to block, interrupt, and break. To block and interrupt and break. That is small part of code. And for critical section is a small. This is a part of code. A part of code. Maybe it is not a few lines of the code, which allow only one thread. This is interrupt or break generated by the OS. And maybe sometimes interrupt or break is related to thread. But for me, the atomic operation used for a small of code when you write a few code, the code atomic maybe run only in the a few line, 3 or 5 line, 3 or 5 line of code, and the critical section may be longer than, and it is allow only one thread to run in access resource. And this one test have or also remaining occur interrupt, not protect interrupt. Here in this protect interrupt or break, and here the interrupt when you have the high priority, very high priority process may be interrupt for in this thread to access the resource, not protect interrupt. Here this is not interrupt, not interrupt. Interrupt cannot block. Here interrupt can block. This is a different from the atomic operation and critical section. Now the word that is the deadlock. The deadlock is a problem when two or more processes are unable to do the work because they wait for each other to do something by any one start the first. Concept of deadlock like this when you come to the cross section and to come to the same time, they come to the same time, and they cannot hit, not hit, but and they are waiting for anyone escape. For anyone escape, it is output from generate from thread. This is like this. We call deadlock. For the deadlock example here in this deadlock, I have a program. The program concept have Mr. A and Mr. B. Mr. A have Mr. B A house and Mr. B have Mr. B house. This is an idea, concept idea, and Mr. A, Mr. B, and draw, lock, and unlock. This is a concept you can use in this. You may be generate a program look like this. Here, Mr. A have a button. A button. When Mr. A press the button to remote to lock the Mr. B house, the Mr. B house have a button. When Mr. B press the button, will generate a signal to lock the Mr. A house. That means when Mr. A come to his home, Mr. B A can lock Mr. B house. And again, Mr. B come to his home, Mr. B can lock to the Mr. A house. When and in the Mr. A come first and Mr. B come late, Mr. A lock the Mr. B home. This is not happen the deadlock. But here when Mr. A and Mr. B come to the home at the same time. At the same time, Mr. A locks here, lock house the Mr. B and Mr. B locks. So they lock for each other. Like this. This is generate the deadlock. This problem occur when you share the resource and you need to lock some resource. Example, I use the USB drive on the on the on the USB hub. Maybe I need to lock the USB drive to access only one device, and maybe it is maybe generate the deadlock. This is an example. Here I show the code for the deadlock. In this code, like as the slide that I show you, this code have two thread in each test have codes in my counter to counting from 0 to 1 million. And here this is with after Mr. A come to house, this is count 1 to 1 million and waiting. And this is mutek 2, mutek 1, this is lock like this. The function 2 is mutek 2 locks. Look as here. this. This is a function one have move take one lock and and move to the loop and move take two locks move to the loops. For the function two lock move take two first and then run the loop and move take one first move take one the second. นี่ output like this. Here in this, I show the difference. Here in this is a thread 1, thread A and thread B, thread A and thread B join, and this is a finish counting. And I click start. If it's finished, it will, this is program stop. Program stop. This is deadlock. Program stop cannot run the code below. The code below will display G. If you look at here, the output the output of the program will show about the G equal the value. Here this is the code stop because not stop the code. The codes have infinite loop for waiting for each other. Here this is generate deadlock, and when you occur the deadlock, your program doing like as uh, run in infinite loop. The problem when you run infinite loop is the processor do the not the work not do the auto works, run 100% to run infinite loop or waiting response from each other. That is maybe your system will slow down and your system maybe crash because the deadlock problem. The deadlock problem will occur both hardware and software when you generate the sequence of lock and unlock and incorrect. Okay, here I change the value and the outputs have the same. It generate the deadlock problem. Okay, here this is I explain to you about the deadlock. And now we will talk about the Livelocks. What is the Livelock? Livelock is a problem that is two or more process change the working stage to avoid the corrosion. But there is the move to the same solution the same way. Therefore, occur a large loop for finding a way to solve the solution. The concept like this: the Mr. A walks a walking path, a Mr. B walking path in the same way. Mr. A waits for Mr. B moving out, and so Mr. B wait for Mr. A. And then Mr. A move on the left, so the Mr. B move on the left to escape from the Mr. B too. Here in this is a Livelock. Then Mr. A move back to the right. Mr. B move to the right too. Mr. A move again to the left, and Mr. B move to the left too. From this sequence is generated Livelocks. We call this is problem with the Livelock. That is look like as the deadlock, but and also both deadlock and Livelock is not generate the outputs and maybe reduce the performance or totally on the system. Finally, here I think this is the last line. The last slide we talk about the starvation. The starvation. The starvation is a process or a process or a threat having a very low priorities, very low priority. In this picture, I suppose this thread from this Java is a very low priorities. In this is a queue line. By the this is a high priority. Yeah, this is very low priority. This is high priority. So the very low priority waiting for response from the scheduler. Scheduler schedule by queue and and the process have all of a lot of high priority works. A lot of high priority works. Yeah. So the high priority is selected first. So the output is will generate some thread. This is waiting for very long time. Waiting very long time. It will be starvation. Maybe this is occur when this is very low thread. Example, I set the thread for virus scanning in your system, and most of the virus scanner software set very low priority. If not managed the base management in the operating system, the very low priority not happen to the select to run on the CPU. For here, the most of the operating system will increase the priority when the starvation threat or threat is waiting for a long time, maybe change status from low priority to medium priority, and well, for waiting for a long time again, change from medium priority to be the high priority. So that this process will be in the queue for select running in the CPU. Yeah, this is starvation. For conclude in this chapter, I think you understand the word about the single thread, multi-thread, atomic operation, critical section, deadlock, Livelock, mutual exclusion, uh, race condition, and starvation. And also you know about the C++ language to write the code about the multi-thread. You can download the code here that I show you on the video. You can download from the internet from the link in the my slide website. Slide the download the goes to the slide that you can and you have a link for to download the example course. Okay, for today, and thank you. Bye bye. See you next chapter.